Howdy folks, welcome. In this video, I'm just going to quick go through the practice test. So the first practice test, again, just to kind of give you an idea as to how I would go about solving the problems. Again, I recognize it's by no means the only way, and in some cases it might not be the way that makes the most sense to you, but I had to have a starting point somewhere. So this is just how I go about solving the problems. Again, there's no rule that says you have to do it exactly the way I do it here. But if you're curious as to where to start, hopefully this can provide a little bit of insight for you with regards to that. All right, so again, to find the practice test, you can go to the course on the Pearson website. So you can just go to MAT165 here. And then along the left-hand side, you should see assignments. So you can go ahead and select that. And you want to make sure that you have all assignments selected here. So sometimes it might default to homework, in which case you won't be able to see the practice test. But if you select all assignments, you should see practice test 1 right there. All right, so let's go ahead and click that and open that. All right, and yeah, go ahead and click start test here. All right, so again, the test will cover everything from the beginning of a semester up through what we covered in class last Thursday. So starting off with section 1 here, so dealing with solving linear equations. So here we have the equation 10 plus 3y equals 7 times y minus 1. Right? So again, the first step is you want to simplify on both sides of the equal sign. So the simplification process kind of involves 2 main steps. So the first step is to distribute if you can distribute. In this case, we can't distribute anything on the left-hand side. However, on the right-hand side, we can distribute the 7 through here. So what distribute means is you're just taking whatever you're multiplying out front, and you're just going to multiply each of your terms inside the set of parentheses by that. So the left side is just going to stay as it is. And then we have 7 times y, so that's going to get us 7y. And then 7 times the negative 1 is going to be minus 7. And the second part, so after you distribute, the second part would be to combine like terms. So if you have anything that involves the same variable raised to the same power on either side of your equal sign, you can combine those into a single term there. In this case, on both sides of our equal sign, both terms are unique. So there are no like terms. So at this point, we can't really combine like terms. So this is as simplified as you can get it on both sides of the equal sign. All right, so once you've simplified both sides of the equal sign, your next step is you want to get everything involving the variable that you want to solve for on one side and everything that does not involve the variable that you want to solve for over on the other side. So in this case, you want to get everything that involves a y on one side and everything that doesn't involve our variable y on the other side. So to do that, we can subtract the 3y from each side. Again, as long as I add or subtract the same thing on both sides of the equal sign, I'm safe. I haven't changed my solution set at all there. All right, so when we do that, we end up with 10 equals 7y minus 3y. So we can just combine the like terms there. So we have 4y minus 7. All right, so now we want to get everything that doesn't involve my y over to the left hand side. So to do that, we can add a 7 to each side. So we end up with 17 equals 4y. All right, so once you have it, so you have everything involving your variable on one side, everything that doesn't involve your variable over on the other side, you can just divide by the coefficient or the number in front of your variable. All right, so again, as long as you multiply or divide the same thing on both sides of the equal sign, we're safe. We haven't changed our solutions at all. So our equations are going to be equivalent. So what we're left with is we have y equals 17 over 4. All right, and again, These questions are really nice because they kind of have a built-in way that you can check to make sure. So if I plug in 17 over 4 in for y, I should end up with the same thing on the left-hand side as on the right-hand side. There. So if I take 10 plus 3 times 17 over 4, I end up with 22.75. And if I take 7 times 17 over 4 minus 1, I end up with 22.75. So I end up with the same thing on both sides of the equal sign. So that means that I have a solution to my equation. All right. Next problem here is an equation dealing with fractions. So we have 1/2 x plus 1/3 equals 1/5 x minus 1/6. So in this case, you have an equation dealing with fractions where we don't have a variable in the denominator. So all of my variables are still in the numerators of my fraction. All right, so to solve this, what we're going to do is we're going to get rid of the fractions by multiplying by my least common denominator. So again, to find your least common denominator, you start off with your largest number. So in this case, starting off with 6. And I'm just going to take multiples of that number until eventually I come into something that 2, 3, 5, and 6 all go into. All right, so I just start with off taking multiples of 6. So you have 6. 5 doesn't go into 6, so that's not going to be my least common denominator. So I take 6 times 2. So 6 times 2 is going to be 12. 5 doesn't go into 12 either, so that's not going to be my least common denominator. Moving on, 6 times 3 is going to be 18. Same reason, 5 doesn't go into 18. 6 times 4 is going to be 24. 5 doesn't go into 24. Until finally, we end up with 6 times 5, which gets us 30. So 5 does go into 30. 3 also goes into 30, as well as 2 goes into 30. So that's going to be my least common denominator for this set of fractions here. All right, so I'm just going to multiply that least common denominator times each of my terms in my equation. All right, and the way this works out is because the least common denominator, every single one of my denominators are factors of that, so they all go into that. We're going to be able to cancel out with all my factors. So 2 goes into 30 15 times, 3 goes into 30 10 times, 5 goes into 30 6 times, and 6 goes into 30 5 times. All right, so what I'm left with after I remove all the denominators, again by multiplying by my least common denominator, I have 15x plus 10 equals 6x minus 5. All right, which again, to solve this, I want to get everything involving my variable x on one side, everything else over on the other side. So I can subtract a 6x from each side, subtract a 10 from each side. So 15x minus 6x, that's going to be 9x. And then negative 5 minus 10 is going to be negative 15. All right, so then we can again divide by the coefficient in front of our x. So we end up with x equals negative 15 over 9. And again, if you're curious as to whether you have the right answer or not, one way that you can check is you can plug in that value into your original equation. So you have 1/2 x, which is negative 15 over 9, plus 1/3. So I end up with negative 1/2 on the left-hand side. And then if I take 1/5 times negative 15 over 9 minus 1/6, I also end up with negative 1/2. So again, that checks out. So that means that that is going to be a solution to this equation. Negative 15 over 9. All right. So the next type of equation that we looked at was an equation where you have a variable in the denominator. All right, so here I have 1 over w minus 1 minus 3 over 5w minus 5 equals 2 over 5w minus 5. All right, so the process that we use to solve this is going to be fairly similar to our previous example. The only thing that's changing is finding your least common denominator. All right, so in this case, your first step would be to factor all of your denominators. So in this case, my first one, so I have w minus 1, so that's already factored for us. The second one, we have a common factor of 5 that we can factor out. So you have 5 times w minus 1. And likewise with my third fraction here, that's also going to be 5 times w minus 1. All right, so then your least common denominator in this case is going to be the product of each of your unique factors. So you have w minus 1, and then we have times 5. Then we don't need to include the w minus 1 again because we've already accounted for that. And over on this side, we've already accounted for the 5 and the w minus 1. So this is going to be my least common denominator. So 5 times w minus 1, or 5w minus 5. Which again, you're just going to multiply each of your terms by that least common denominator. Right. For this first one here, the w minus 1s will cancel. Here they both end up canceling. And here they also both end up canceling. All right, so what we're left with is 5 minus 3 equals 2, which 5 minus 3 is going to be 2, so 2 equals 2, which is true regardless of what value I have for my w. In this case, my equation doesn't depend upon my value for w. So in this case, again, that's what's known as an identity. So identity means that it's true for every meaningful value of your variable. And I'll get to what meaningful values mean a little bit later here. So yeah, so in this case, the equation has an identity. So in this case, the solution set, so most of the time when we have an equation that's an identity, the solution set is all real numbers. This is one of those cases where that's not necessarily the case, because in this case, we can't divide by 0. So we need to exclude any numbers that lead to division by 0 in my original problem. So in this case, my solution set is going to be all values w, but w cannot be something that leads to 0. So in order to get a 0 in my denominator, I need w minus 1 to equal 0, which means that w would have to equal 1. So that's going to be the value that we exclude from our domain. And yeah, that works with the other two fractions as well. So 5w minus 5 is only going to be 0 when w equals 1 as well there. All right, so the next one here, we have z plus 4 divided by z minus 8 equals 11 divided by negative 7. All right. So in this case, again, we can multiply by my least common denominator. So again, in this case, both denominators are factored. So my least common denominator is going to be z minus 8, and then also negative 7 times that. All right, so again, you're just going to multiply each of your terms by that. Again, on the left-hand side, the z minus 8 is going to cancel. On the right-hand side, negative 7 is going to cancel there. All right, so you have negative 7 times z plus 4 equals 11 times z minus 8. All right, so we can simplify, so we can distribute on both sides here. So you have negative 7z minus 28 equals 11z minus 88. All right, so we want to get everything involving our variable z on one side, everything else over on the other side. So we can add 7z to each side, add 88 to each side. So negative 28 plus 88 is going to be 60. And 11z plus 7z is going to be 18z. So we can divide both sides by 18. With z equals 60 over 18, which we can simplify as 30 over 9. So we can divide the top and bottom by 2. So that is what the answer should be there. And again, you need to make sure that it doesn't lead to 0 and any denominators. In this case, the main thing we need to worry about is if z equals positive 8, which 30 over 9 does not equal positive 8, so we're safe there. So the solution set is going to be 30 over 9. And in this case, you have a conditional equation. All right, so next one here, so we have 2 over z minus 3 minus 2 over z plus 3 equals 12 over z squared minus 9. All right, so again, the first step would be to factor my denominators. In this case, the first two are already factored. This last one here, so you can use the difference of squares rule. So z squared minus 9 is the same as z squared minus 3 squared. So when you factor this, that's just going to be z plus 3 times z minus 3. So you just take your first term plus your second term, and then your first term minus your second term. All right, so then my least common denominator in this instance is going to be z minus 3 times z plus 3. Again, when I go on to this next one, I've already accounted for the z plus 3, so I don't need to include that again. And I've also accounted for the z minus 3, so I don't need to include that either. So that is going to be my least common denominator. So again, you multiply each term by that least common denominator. All right. And again, we can cancel out common factors here. So what we're left with is 2 times z plus 3 minus 2 times z minus 3 equals 12. So we have 2z plus 6 minus 2z plus 6. This equals 12. So the 2z and the minus 2z will cancel. So you end up with 12 equals 12, which again is true regardless of what value you choose for your variable z. So in this case, again, we have an identity, which again, at this point, the main thing we need to worry about is what leads to division by 0. So in this case, I divide by 0. I have 0 in the denominator. If z equals positive 3 or z equals negative 3. So I exclude both those from my solution set. All right, so next one here, so I have 2y divided by y plus 4 equals 6 minus 8 divided by y plus 4. All right, so this is like 6 over 1 here. All right, so again, my least common denominator is going to be y plus 4 in this case. I guess technically multiplied by 1, but if you multiply something by 1, it's the same as before. So yep, so I'm just going to multiply everything by y plus 4. So there the y plus 4's will cancel. Here the y plus 4's will cancel. So we have 2y equals 6y plus 24 minus 8. So we have 2y equals 6y plus 24 minus 8 would be let's see, 24 minus 8 would be 16, I think. It's embarrassing that I don't know that. Yeah, okay. For some reason, I was just second guessing myself. All right. Then we subtract the 6y from each side to get all my y's on the other side. So we have negative 4y equals 16, which again, you can divide both sides by negative 4 to end up with your solution of y equals negative 4. All right? So if you say y equals negative 4, you run into some issues because if y equals negative 4, then if we look up top at our original problem, we end up dividing by 0, which at this point, this is one of the primary rules that we have for this section is you can't divide by 0. So in this case, the only value that works for the numerators doesn't work for the denominators. So in this case, there is no solution. This is what's known as an inconsistent equation or a contradiction. Sometimes you hear it referred to as that. All right. Whew. A lot of dealing with rational equations. On the exam, so every once in a while these practice exams can be a little bit overwhelming because there's a lot of problems. On the exam, generally there are fewer questions than on the practice exam. So on the practice exam, I want to cover my bases. So I create multiple different copies of the exam. So some students may have some questions. Some students might not have the same set of questions. So yeah, so I want to cover my bases because I don't know which test you guys are going to get or each of you is going to get. So yeah, so this kind of includes all the different possibilities that can occur. So if it shows up on the practice test, It is a candidate to show up on the actual test, although that's by no means an exclusive there. So, yeah, so again, there's probably going to be fewer questions on the actual exam than the practice exam. So don't let the practice exam overwhelm you. Again, this is just me trying to cover my bases there. All right, so the next equation here is we have an equation involving the absolute value. So the absolute value of an expression is denoted by the little bars on the left and right hand side of the expression there. All right, so to solve an absolute value equation, you want to start off, you want to isolate the absolute value all by itself on one side. So in this case, we can add 30 to each side. So we have 5 times the absolute value of y plus 4 equals 30. Then we can divide both sides by 5 to get it so we already just have the absolute value all by itself. So you have y plus 4 equals 30 over 5, which is equal to 6. All right. So the absolute value, again, represents the distance between that number and 0 on a number line. So kind of the informal definition for the absolute value is if we're dealing with a positive number, it's just going to be that number. If we're dealing with a negative number, we just ignore the negative sign there. So in this case, there are two things that when I take the absolute value, get me positive 6. So we have y plus 4 could equal positive 6. But also, if I take the absolute value of negative 6, I also end up with 6. So we have y plus 4 could equal negative 6. All right, so then you can solve each of these equations for a y by subtracting a 4 from each side. So you end up with y equals 6 minus 4, which is going to be 2. And negative 6 minus 4 is going to be negative 10. So those are going to be my two answers. Again, just remember that the absolute value always has to be positive. So if you have the absolute value of an expression equaling a negative number, then you know right off the bat that it's going to be a contradiction or inconsistent, and therefore have no solution. All right. All right, so the next kind of set of questions was dealing with linear functions and modeling applications with linear functions. So it started off with finding solutions to formulas. So again, same rules apply that we talked about earlier, only in this case, instead of just dealing with numbers, we also are dealing with variables as well. All right, so if I have the equation P equals 7 over 2 times the quantity M plus 26, and I want to solve this equation for M. All right, so again, just like before, the main thing we want to do is we want to get everything involving the variable that we want to solve for on one side and everything that doesn't involve the variable that we want to solve for over on the other side. All right, so to do that, I can subtract the 26 from each side. Again, the same rules apply. So we have P minus 26 equals 7 over 2 times M. And to get it, so I have M equals something. You can divide both sides by 7 over 2, or you can also multiply it by the reciprocal of your fraction. So you can multiply both sides by 2 over 7. So the 2's will cancel, the 7's will cancel, so we're just going to be left with M on that side. And we have, depending on how you want to write it, I'm fine if you leave it like this. So 2 over 7 times P minus 26. I'm fine if you leave it like that. If you choose to distribute the 2 over 7 through, you could have 2 sevenths P minus 26 times 2 sevenths. So that would be 52 over 7. I'm fine if you have it all in one fraction. So you could have 2P minus 52 over 7. Yeah, whichever form you want to write it in doesn't really make too much difference to me. All right. 2/7 times p minus 26. Here, same type of problem. So we have b equals s plus f minus 8 times t. And we want to solve this formula for f. So we want to end up with f equals something. All right, so again, your first step is you want to get everything involving your variable that I want to solve for on one side, everything that doesn't over on the other side. So I can subtract an s from each side. So we have b minus s equals f minus 8 times t. Then we can divide both sides by t here. So you have b minus s over t equals f minus 8. And you get f all by itself. You can just add an 8 to each side. So you have b minus s over t plus 8. And yeah, 8 is separate. So we're not just adding 8 to the numerator here. Fortunately, I didn't leave myself enough space with the equal sign there. All right, so that is going to be my answer there. All right, so b minus s over t plus 8. All right. So the next couple of problems are dealing with specific types of problems that we talked about in class and that we looked at in the homework. So the first problem here is dealing with a geometric formula. So word kind of on this. If you're required to know a geometric formula on the exam, I will give it to you. So you don't have to worry about going home and memorizing all the different perimeter and area formulas just because they might show up on the exam. So I'll often give you the formula that you need to use in the exam, in the question. Generally, I have that as a hint at the end of the question. So I'll say like, hence the formula for the perimeter for a rectangle is p equals 2 times length plus 2 times width, or something like that. All right. So here you have a carpenter used 37 feet of molding in 3 pieces to trim a garage door. If the long piece is 1 foot longer than twice the length of each short piece, then how long is each piece going to be? All right, so in this case, we have 3 pieces because we're not applying molding to the bottom of my garage. And we have the short piece is my X. And here we have my long piece. So it says the long piece is 1 foot longer than twice the length of each short piece. So that's going to be 1 plus 2x. And have the other short piece on the other side. All right. So if we add up each of these lengths, so x plus 1 plus 2x plus x, that's going to equal the total number of feet of molding that we used. So that's going to equal 37. So this is my equation here. All right. So when I combine my terms, x plus 2x plus x, that's going to be 4x plus 1 equals 37. So you can subtract a 1 from each side. We have 4x equals 36, which again we can divide both sides by 4. So you have x equals 9. All right. And again, once we've solved our equation, we have to ask ourselves the 2 questions. The first question, does the answer make sense? Does it physically fit the constraints of the problem? Again, the main thing we need to worry about at this stage is if you end up with a negative number. You had to have a negative dimension for either your length or your width there. In this case, we end up with a positive number, so we're good there. The second question you have to ask yourself is, does it actually answer what the original problem is asking? So in this case, the original problem is asking for the lengths of both of the pieces, or both types of pieces. So again, X represents the length of my short piece. So then I still need to find the length for my long piece, which again is going to be 1 foot longer than twice the length of my short piece. So if my short piece is 9, I take twice that length, so that gets me 18, and then I add 1 foot to that. So my longer piece is going to be 19 feet long. All right. Next problems here are dealing with mixture problems. So here we asked how much of an 80% antifreeze solution must be mixed with 60 gallons of a 10% antifreeze solution. 60 gallons there. We don't know how much for the 80% in order to get a mixture that is 70% antifreeze. And the volume on this is going to be X plus the 60 gallons. So it's however many gallons we're adding plus the original 60. Right, so then your equation is going to be found by taking your percentages and multiplying by your volumes. So you have 80x plus 10 times 60 equals 70 times x plus 60. And again, you can use the decimal as your percentage. You could do 0.8, 0.1, and 0.7. I just prefer to work with whole numbers if I can. So yeah, so I just use the percentages themselves. You can get away with it in this problem because again, what in effect we're doing is we're just multiplying everything by 100. Later on, there will be some problems where we do have to actually use the decimal for our percentages. In this case, you can do either. All right. So yeah, so just doing some of the arithmetic here. So again, simplifying. So 10 times 60 is going to be 600. And then if I distribute the 70 through, and it was 70x, and 70 times 60 is going to be 4,200. All right, so again, you want to get everything on your variable that you want to solve for on one side, everything else on the other side. So you can subtract the 600 from each side, subtract 70x from each side. What we're left with is 10x equals 4,200 minus 600 is going to be 3,600. All right, which again, once you get everything involving your variable on one side, everything else over on the other side, you just divide by your coefficient. So you end up with x equals 360. Which again, you have to ask yourself 2 questions. On the first question, does the answer make sense? Again, the main thing we need to worry about is if you end up with a negative number here, because there's not a way that we can take volume away. There. So in this case, we do end up with positive, so we're fine with regards to the first question. And the second question is, does it actually answer what the original problem is asking? So again, X represents the amount of the 80% solution, which I believe is what we were trying to find. Yep, so yeah, so it's asking how many gallons of the 80% solution there. So in this case, I need 360 gallons. All right. All right, so the next question here is dealing with a work rate problem. So again, the main formula to remember from this is the amount of work completed is equal to the rate times the time. All right, so in this case, we have two crime fighters. So yeah, so I like this problem just because I imagine like superheroes and stuff like that. And yeah, still kind of a child at heart when it comes to that sort of thing. So yeah, so we have two crime fighters. So person X can clean up all the crime in the city in 4 hours working alone. So the rate at which person X can clean up crime is going to be 1/4 of the city per hour. So my R sub X, so the rate at which the first person or person X can clean up is going to be 1/4 of the city per hour. Person Y can do the same job alone in 10 hours. So his rate is going to be 1/10 of the city per hour. All right. So if person Y starts fighting crime at 8 a.m., most of the time when you think about superheroes and other things like that, a lot of times they end up working at night. So it's kind of weird to have them working during the daytime, which again doesn't necessarily say that they're superheroes. But yeah, that's kind of the way I like to imagine it there. All right, so person Y starts at 8 a.m. and person X joins him at 11 a.m. there. All right, so that means that he is working at 1/10 of the crime per hour, and he's working by himself for 3 hours because from 8 a.m. to 11 a.m. is 3 hours there. All right, and then they're both going to be working. So we have 1/4 plus 1/10. So this represents the amount of crime that they can clean up, both working together. And we don't know how long that is. And the total number of cities is going to be 1. All right, so this is my equation here. So you have 3/10 plus, all right, we have a common factor, or we common multiple of 20. So 1/4 is going to be 5/20. And 1/10 is going to be 2/20. So we have plus 7/20 times t equals 1. Right, so again, we want to solve for t here. So we subtract 3/10. So we have 7/20 times t equals 1 minus 3/10, which is going to be 7/10, because 1 is 10/10. All right, and again, you can multiply or divide both sides by 7/20, or you can just multiply by the reciprocal. So most of the time I just multiply by the reciprocal. What we're left with is t equals, so here the 7s will cancel. Here the 10 goes into 20 twice. So in this case, t equals 2 hours. Which again, at this point, you need to ask yourself the two questions. The first question, does the answer make sense? Does it seem physically reasonable? Again, like before, assuming that nobody has like time travel powers or anything like that, you need to end up with a positive number for your time, which in this case, we do end up with a positive number, so we're safe within that regard. The second question is, does it actually answer what the original problem is asking? So the original question is asking, at what time will they have all the crime cleaned up? So again, my t represents the amount of time they spend working together. So if they start working together at 11 a.m. and they spend 2 hours, that means that they will be done by 1 p.m. Because you have 11, then you have noon, and then 1. All right. So the next thing here is the distance and midpoint. So these are just some formulas that you just kind of need to have memorized for this exam. So the distance formula and the midpoint formula. So again, distance is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's going to be your distance formula. And then your midpoint, so again, your distance is going to get you a single number, whereas your midpoint is going to get you a point. So again, with the midpoint, you can have an x-coordinate and a y-coordinate. The x-coordinate is going to be x1 plus x2 divided by 2, so the average of your x values, and then your y-coordinate is going to be y1 plus y2 divided by 2, the average of your y values. All right, so in this case, I have the 2 points, 7, 2, and -1, -4. All right, so again, your coordinates are listed with the x value first, so you follow the rules of the alphabet. So you have x1, so 2 is going to be y1, -1 is going to be x2, and -4 is going to be y2 there. All right, so the distance is going to be the square root of x2, which is -1, minus x1, which is going to be 7 squared, plus y2, which is going to be -4, minus your y1, which is going to be 2 squared. All right, which when we do the arithmetic here, -1 minus 7 is going to be -8 squared. -4 minus 2 is going to be -6 squared. So that's going to be 64. Again, had a student come in that was running into some issues with regards to this. So when you're entering in negative numbers and you're squaring those in the calculator, you need to make sure that you include parentheses around the negative number. Because in this case, if you don't include the parentheses, so if you just have -8 squared, it's going to take 8 squared and it's going to multiply that times -1. So yeah, so when you have parentheses, you want to make sure that you include those in your calculator there. All right, and then -6 squared is going to be 36. So 64 plus 36, I believe, is 100. So you have the square root of 100, which is going to equal 10. So the distance, so this is kind of as the crow flies between the 2 points, is going to be 10 there. All right, so again, with your distance, you're just going to get a single number. With the midpoint, again, you're going to have a point. So you're going to have an x-coordinate and a y-coordinate. All right, so again, your x-coordinate is going to be 7 plus -1, so x2 or x1 plus x2 divided by 2. And then your y-coordinate is going to be y1 plus y2, so we have 2 plus a -4 divided by 2. All right, so 7 plus a -1, so that's going to be 6 over 2, and 2 plus a -4 is going to be -2 over 2. So this is going to be 3, -1. 3, -1. All right, so again, I need to have a point. Why do I have 2 blank pages stapled together? All right. So yeah, so again, your point consists of an x-coordinate and a y-coordinate. Where the distance, you're just going to get a number. All right. Next couple questions are dealing with finding equations for circles. So going from the general form to the center radius form. All right, so here you have the general form for an equation for a circle is we have x squared plus 6x plus y squared minus 3y equals -1/4. All right, and we're asked to find the center and the radius of this circle. So again, your first step in converting from general form to center radius form is to make sure that you have all your variables on one side and your constant term over on the other side. In this case, that step's already done for us, so we don't need to worry about that. The next thing we need to do is we're going to complete the square for your x and your y. All right, so again, how completing the square works is you want to rewrite this x squared plus 6x as something raised to the second power. So what goes inside the parentheses here is going to be your variable, and they're just going to take 1/2 of whatever's in front of your linear term. So in this case, I'm going to take 1/2 of positive 6, which is going to be positive 3. So that's going to be the other thing that comes inside this parentheses. Which again, when I expand this out, so if I take x plus 3 times x plus 3, I'm going to end up with x times x, which will give me the x squared. Then I have x times 3, which is going to be 3x. Then I have 3 times x, which is going to be 3x again. So 3x plus 3x gives me the 6x. But then I also have the final two terms. So we have 3 times 3, which is going to be positive 9. So I don't have that up here. So in order to account for that, I'm just going to add that to my original. And again, if I add something on the left-hand side, I have to add the same thing on the right. All right. And then you're going to do the same thing with your y values. So you have y squared minus 3y. So again, we're going to take y, and then 1/2 of negative 3 is going to be minus 3 over 2, minus 3/2. Which again, when I expand this out, I'm going to be missing a term, and the term that I'm going to be missing is just going to be my constant term raised to the second power. So 3 over 2 squared is going to be 9 over 4. Because again, if you're multiplying and dividing and you square that, you can square the top and the bottom. All right, so I'm just going to add 9 over 4 to each side. All right, so what I'm left with is I have x plus 3 squared plus y minus 3 over 2 squared. So if I take negative 1/4 plus 9 plus 9/4, negative 1/4 plus 9 plus 9/4 gets me 11. All right. Which again, if I have the equation, the center radius form for the circle is x minus h squared plus y minus k squared equals r squared. Where h and k represent the x and y coordinates of your center, respectively, and your r represents your radius. So in this case, my center is going to be, again, we just keep the same numbers, but we just switch the signs. So you have negative 3 over 2, and your radius is going to be the square root of 11. Square root of 11. So yeah, so here we just have another example here. So we have x squared. Again, first step is to get it so you have your variables on one side and your constant term over on the other side. So I'm just going to add 6x and subtract 8y. Then again, we kind of rearrange things so that I have my x's together and my y's together. So you have x squared plus 6x. Then we have plus y squared minus 8y equals 0. All right. So again, just going to complete the square. So the first part here, so we have x, and then we're going to take 1/2, again, with whatever is in front of our linear term. So 1/2 of 6 is going to be positive 3. Which again, to figure out what I need to add, I'm just going to take this number and square it. So 3 squared is going to be 9. So I'm just going to add a 9 to each side. And likewise for my y, I'm going to have y 1/2 of -8 is going to be -4. Which again, when I square this, I end up with positive 16. So I end up with 9 plus 16, which is going to be 25. All right, so then my center going to be -3, 4, and my radius is going to be 5. All right. So yeah, so again, just wanted to give you some more practice dealing with completing the square to find your center and radius. On the exam, I'm not going to have you graph a circle. As a rule, I don't like graphing questions, so I try to avoid those if possible. Sometimes they can't be avoided, but yeah, in this case, the main thing I want to get at is not that you know how to draw a perfect circle, but that you know the center and the radius and how to find those for a given circle. But just so I don't get it wrong, I am going to go ahead and graph it here. So you have a center at -3, 4, -3. All right, and then a radius of 5. So it's going to go from -3 to +2. There you go, 5 units in that direction. So -3 plus 5 gets you +2. All right, so that should be the graph. And lastly, right after I say that I don't like graphing questions, and that still remains the case, however, I do want to make sure that you know what the graph of a line looks like and how to graph a line. So yeah, so I will have a graphing question where I ask you to graph a line on the exam. So, yeah, so in this case, it's asking for the line 3x minus 2y equals 12. All right. So to graph this, we can find our intercepts. So your x-intercept and your y-intercept. All right, so again, your x-intercept is going to be when your y value is equal to 0. So to find your x-intercept, you can just ignore the y part. So you have 3x equals 12, and then you can solve that for x. So we can divide both sides by 3, and we end up with x equals 4. So in this case, our x-intercept is going to be x equals 4 and y equals 0. All right, and then find your y-intercept, kind of in a similar vein. So you're going to set your x value equal to 0, so you can just ignore the x part, and then you solve the equation for y. So you have -2y equals 12. So that means that y is going to equal -6. So my y-intercept is going to have x coordinate of 0 and a y coordinate of -6. X-intercept is 4, 0. And the y-intercept is 0 and -6. Graph this. So we have 6 and 4, 0. All right. So I think that is everything. So let's go ahead and submit this and see how we did. Yes. Uh-oh. What did we do wrong? Okay, yep. So that one I just forgot to simplify. So yeah, so you have a common factor of 3 there. So yeah, so that's -5/3. Man, I was just not having a feeling like simplifying today. So yeah, so in this case, same thing. So again, you have a common factor of 3. So 30/9 is the same as 10/3 from there. So that one I just put a decimal point instead of a comma there. So yeah, so that's just a typo. Okay. All right. So yeah, so not perfect, but yeah, at least I knew where it went wrong there. All right, so yeah, so again, that's just how I go about solving the problems. Again, if you have a way that makes more sense to you, you can go ahead and use that method as well. You don't necessarily have to be tied down to the exact methods that I use here. This is just to hopefully give you an idea if you're not quite sure where to start. So hopefully you found this valuable. Yeah, have a great day, and I'll talk to you all later. Bye now.